Okay, so today I'm going to be talking about the removal of inverse properties from GIST. And I know a lot of you will be familiar with this. And our last major release, GIST 12, which we released back in July, we removed all of the inverse properties from GIST, 19 in total. And at the time, we had just under 100 object properties in all of GIST. So this made for a pretty substantial trimming of the ontology with the removal of these properties. And so my focus is going to be on why did we do this? Why did we remove the inverse properties, and how do we go about doing it? And to that end, I'm going to discuss a number of different things. First, I'm going to talk about some essential background on inverse properties. Then I'm going to talk about a summary of the changes that we actually made in GIST in the latest update. And I'll try to make the case for why we removed the inverses. And then I'm going to discuss, well, how do we choose which inverses to keep, which perspective to maintain within GIST. And then I'll end things by a discussion of the practical benefits that we've already seen with some of our clients. And I'm going to try to get through a lot of things, but people can feel free to ask questions or interrupt me at any point. Okay, so starting with some essential background on inverse properties, just so we're all on the same page. A lot of this will be familiar to many of you. If you're familiar with RDF, you know that RDF triples have a subject, a predicate, and an object. And so you can express triples like the following. Taylor Swift has album 1989, which I think she re-released this week. But if you want to say the exact same thing, if you want to express the exact same relationship, taking the opposite perspective or using the opposite direction, you can do so with an inverse property. So you can say something like 1989 is album by Taylor Swift. You're saying essentially the exact same thing, but you're just taking the other perspective. And so is album by is the inverse of has album, right? And I'm going to borrow a metaphor from Michael Ushold here. You can think of inverses as being two sides of the same coin. You know, you're talking about the same relationship, but you're just taking different perspectives on it, right? And so here are a few more examples. Has parent, is parent of, precedes versus follows, has part versus is part of. These are all inverse relationships. Okay, so within the web ontology language, within OWL, you can formally define inverses. You can give a name to an inverse and formally define it. Here's an example of an inverse that we used to have in GIST. We don't have it in there anymore, but this was a definition of GIST effects. Within OWL, you can explicitly say that it's the inverse of GIST is affected by. And then once you do that, you can get certain inference behavior. Given inference rules, you can expect to get certain triples to be inferred based on that explicit statement that GIST effects is the inverse of is affected by. Now, importantly, you don't have to give the inverse a name. You don't have to give you don't have to formally define an inverse. There are a couple reasons why this is the case. First off, there's always a sense in which you can assert the same thing without it, right? Going back to that initial example, there are just kind of two ways of saying the same thing. So if you get rid of an inverse, it's not like you're losing out on the ability to say what you need to say, right? You can still express the very same information using one of the predicates rather than the other. And then on top of that, both OWL and Sparkle allow you to take the opposite perspective without naming the inverse. There are a couple ways in which they do that. So within OWL, there's a construct that you could use. You could think of it as an anonymous property. It's kind of similar to an anonymous class, right? Where you can, like a property restriction, where you can refer to a class without giving it an actual name. Well, you can do something similar with properties. You can say, I want to talk about the inverse of GIST effects without saying, you know, GIST is affected by. It means the exact same thing, right? And then similarly in Sparkle, you can use this caret notation to refer to an inverse without using a named inverse. You can say caret just affects. It means the exact same thing as just is affected by, but you're not using that actual name to refer to it, right? And so with that in mind, you might wonder, well, why should you go through the trouble of adding a named inverse to an ontology to begin with, right? If you can always say the exact same thing without an inverse, you can always take this opposite perspective whenever you need to, then why should you add a named inverse to begin with? Well, there are a couple different reasons. One of the reasons is convenience. If you find yourself taking the opposite perspective often in queries or in building out the ontology, then it could just be useful to have that inverse at your disposal, right? Now, on top of that, another reason is clarity. Sometimes when you've got an inverse property that you can use, it's just easier to read or understand, right? You can take a couple sentences for an example here. Taylor Swift has album 1989. Well, that's just easy to read, easy to understand. You can say the same thing using inverse notation. Taylor Swift caret is album by 1989. That it means the same thing technically, but it's just difficult to understand, right? Difficult to parse. And so these are a couple points that I borrowed from one of Michael's white papers, Quantum Entanglement, Flipping Out and Inverse Properties. You can check that out on the Semantic Arts website. Now, okay, so this brings me to the updates that we actually made in GIST. Despite the occasional benefits of convenience and clarity, we decided we're going to remove all of the inverse properties across the board. And again, just to summarize, we had roughly 100 object properties in GIST, and we removed 19 inverse properties. So again, a substantial reduction in property count within the ontology. And you can see here on the left-hand column, these are the properties that we retained in GIST. I won't go through all of them one by one, but you can see which ones we retained in the release notes, and here are the ones that we removed. And so we decided to keep has direct part, but we got rid of is direct part of, for example. Okay, so now on to the case for removing inverses. Why did we decide to remove all of the inverses from GIST? There are a couple principal reasons. I don't think that they are the only reasons, but here are a couple of the central reasons. One of them was related to inference and query performance. When you've got inferencing turned on in a triple store, the presence of inverses can explode triple count, resulting in memory or query performance issues. And then another reason was related to cognitive load. When you have inverses present, it can be difficult to keep track of which predicate was used to express a relationship. And this becomes important especially when you don't have inferencing turned on. You kind of have to remember to yourself, well, okay, when I was mapping the data, which direction did I choose? Which perspective did I actually take when I was mapping the data? And if you're trying to do Sparkle queries, it's going to be important which direction you actually chose. If you happen to remember wrong and you choose the other direction, you're not going to get the results that you expected, right? Okay, so I'm going to talk about both of these reasons in a little more depth. Okay, first off, inference and query performance. When you declare inverses in an ontology, you can expect the following types of inferences. And here I've taken these inference rules straight from the OWL RL spec, and it's exactly the kinds of inference rules you would expect, right? Whenever you declare that one property is an inverse of another, and then you express a relationship using one of those properties, you get the opposite perspective for free, given the inference rule. So for example, going back to that initial one, if I declare that has album is the inverse of is album by, and I declare that Taylor Swift has album 1989, well, the inference is going to be that 1989 is album by Taylor Swift. I'm going to get that given this inference rule. And so consequently, what you're going to end up with is the same number of assertions going in each direction. You're going to get one assertion going in each way. And this is actually something we saw at one of our clients where we had close to 3 million triples that were expressed using the is based on relationship, and we had exactly the same amount of triples expressed going in the opposite direction, just as you would expect given these inference rules. And you might just think, well, that's just, I mean, there's not a whole lot of benefit that you get from having both perspectives there, right? Okay, moving on to cognitive load. There are a couple things related to cognitive load. First has to do with modeling and data mapping. So from a modeling perspective, you just have more predicates to memorize when you've got inverse relationships in your ontology. And you're also going to be confronted with the choice of, well, which property should I be using in the axioms? Now I've got a choice to make. If I'm developing axioms, which of these should I be using? On which classes should I be using which property? From a data mapping standpoint, you might be asking yourself, well, which property should I use when I'm mapping the data? Which perspective should I take? And the question might even come up, well, should I assert both perspectives in the mappings? Okay. And then another thing with cognitive load has to do with querying, which this is a point that I was making earlier. You're going to be frequently asking yourself, well, which property did we actually use when we mapped the data, especially if inferencing is turned off? It's going to matter whether you map the data using the just affects perspective or the is affected by perspective. Okay, so again, despite the benefits of convenience and clarity that you might get occasionally with named inverses, we decided that the considerations related to query performance and cognitive load just weighed heavier. And so the next step beyond that was figuring out, well, which perspective should we maintain in GIST? Which inverses should we actually remove? And at first you might think that maybe it's just kind of a matter of convention. Maybe you should just flip a coin and, it doesn't matter really which perspective you take, as long as you can always express the things that you want to express using these predicates, it doesn't really matter that much. It might be similar to, when countries are choosing which side of the road to drive on, you just have to, as a country, decide which side you're going to drive on, and then it works out after that, right? It doesn't matter whether it's the right or the left-hand side. But we decided that was actually not the attitude to take about the inverses that we were keeping in GIST. We thought, well, maybe there are actually some good reasons to choose one perspective over the other, right? And so we developed a list of criteria. This is not the exhaustive list, but these are some of the main criteria that we used. So one of them was related to ease of understanding and common usage. What's a more common perspective for expressing this relationship? What's the easiest way to understand? Another one was related to just kind of general uniformity. For example, for hierarchical relationships, we maintain a preference for a child to parent perspective or a narrower to broader perspective, as much as we could, kind of across the board. And then another consideration related to cardinality, which I'll talk about in more depth here in a bit. It's related to whether we're dealing with a one-to-many relationship or a many-to-many relationship. We actually developed a working group to apply these criteria. I know me and Mark Wallace and Michael Ushold and Rebecca Eunice were part of this, and a lot of people were part of this discussion. I know Phil helped in developing some of the criteria, and Dave was part of the discussions as well, trying not to leave anybody out. But I want to discuss each of these criteria now and how we applied them. I'm not going to talk about every single decision that we made across the board, but just want to give everybody a sense of how we applied some of these criteria in particular cases. And so the first one, again, was ease of understanding and common usage. What's the more common perspective for expressing this relationship, and which is the easiest way to understand? So take a couple examples here. Just is about versus just is described in. Arguably, maybe it's just easier to understand that Harry Potter is about the book Harry Potter is about wizardry rather than wizardry is described in the book Harry Potter. Just kind of like a more natural way of expressing that fact is to use is about. I think it helps a little bit that is about is shorter. It's not as wordy as is described in. So maybe that's another point in favor of is about. Another precedes versus follows. Maybe it's more natural to think of, one thing as preceding another rather than following it. Maybe it helps that when I say that X precedes Y, that X lexically precedes Y. Maybe that's a reason why it's more natural to think about it in that way. But again, these are not heavy considerations, but these are cases where it was a little bit better than flipping a coin, right? There were some solid reasons in favor of keeping one over the other. Next, uniformity. Again, one of the things we tried to be uniform about was with hierarchical relationships, maintaining a preference for that kind of narrower to broader perspective. And so as you'll see in the properties we kept has supercategory over has subcategory. And we kept has navigational parent over has navigational child. Okay, and then the last criterion was related to cardinality. And here's kind of the way this one worked, or how we were thinking about this one. We kept is geographically contained in over just geographically contains. And kind of one of the ways you can think about this is if you express relationships using geographically contains and you've got some relatively broad regions like the USA, you're going to end up with a long list in your triples, a long list of all the things that are geographically contained within the United States. And, if you choose to express things going in the other direction, that things, you start with the subregions and say what they're geographically contained in, it looks a little bit nicer. So this in some ways you might think of as more of an aesthetic preference, but it is one of those things which points in one direction over the other. And then to add, in this particular case, there was a kicker that is geographically contained in is kind of the narrower to broader perspective anyway. So there are actually a couple reasons for going with this predicate over geographically contains. Okay, so I see Rebecca had a question or comment.
I just think it might be worth pointing out on your last slide that one of the cases for the cardinality was in terms of querying. So querying from narrower to broader, you explore a subcategory, a super category you'll have better query performance because there are fewer results. Yeah,
definitely. Let's see. Yep.
Me?
Yeah.
So I have a question because I agree in principle. This is great. What I do see here is that there is one that you probably have discussed a lot, but I'd like to understand the reasoning. That is the is part of, and you could have argued in both directions for it. And I felt it was strange that it was left out because usually you have, or that I would have expected the inverse to stay because the child would be disconnected from its parent. Whereas if you have is part of instead, you would be able to ensure that you have the referential integrity of all the triples. So it's easier to accidentally lose something that is part of when you remove the parent than the other way around. But there could be other things as well. But that is something that I noticed and I was curious about.
Yeah. No, that's a good one. You're right that it doesn't the particular direction that we maintained, going back here, we chose to retain the has part perspective over the is part of perspective, which might think of, as going against that child to parent direction. And I can't actually remember the main consideration why Rebecca, do you remember?
Yeah. What we actually did is looked at the restrictions in GIST, and in many cases made the decision on what property was being restricted. And it turned out that in the case of has part is part of, and in many others, we found that we're actually using has part in many restrictions, and so we opted for that. That was yet another criterion that we used.
Right.
All right.
Michael has his hand up too. You're muted, Michael.
Sorry, thank you. Rebecca, a moment ago, said that query performance was an issue, and I remember that conversation. What I forget now is, given you can put in a Sparkle query the inverse using the caret, why does it actually matter which direction you choose? How could that impart query performance if you can use either one in the query?
I think in that case, it may not.
Yeah.
Okay, that's fine. So that's interesting. I just had that thought now. But anyway, second question is another way that I think about this, and it was part of the discussion in terms of which direction to go. You know, it's think of it, where are you likely to be asking the question, right? So let's take has part. Are you likely to be on the whole and saying, who are my parts? Or are you more likely to be on the part saying, who is my whole? And arguably, in the case of has part, it's a much less strong argument one direction versus the other. Some of them it's more common, like is about, are you more likely to have a topic and say, tell me about all the millions of documents that are about this topic, or more likely to say, what is this document about? So that's one of the considerations that we brought into the discussion.
That goes hand in hand with the cardinality.
Yes, that's a good point.
Well,
thank you.
I think, yeah.
That's all.
Dave, next hand up.
Yeah. Particularly in relation to the parts question. I think it's always worth remembering that in someone's particular context, you can always add the inverse property in using your own namespace, and then either use that one exclusively, you know, or go ahead and declare it an inverse and then let the reasoner work either way. But sometimes, you know, a particular context would make it far more sensical to say, I want to have this, you know, as the part of, you know.
If I would interject there, I think that you may have, depending on if it's in the query domain that you want the performance of, or if it's a system of record, you would think differently, and you would probably also put in place the necessary inverse, depending on what you're trying to accomplish. So I think that's an important statement as well, as you said.
Yeah, I think there is something to be pointed out here, which is that if you are operating in the context of linked open data in the semantic web, as opposed to in sort of the closed system of enterprises, you actually do need inverses, because you can only publish triples when the subject is in your own namespace. So in that case, you know, you will, if I have an object, Jane Austen, in my namespace, and I want to say she's the author of Pride and Prejudice, which is in your namespace, the only way I can say that is with the predicate going in one direction. The only way you could assert it is with the predicate going in the opposite direction. So when you're working in that context, and this is what I found when I've been working on linked open data projects, is it's actually quite critical to have inverses. So this is a totally different context that has different requirements.
Yeah, I think the message is there's a lot of cases where you might want to use inverses, but we didn't want to impose them on people.
Right. Yep. Yeah, certainly. You know, with our removal of the inverses from GIST, it wouldn't preclude people who are using GIST from minting inverse predicates in their own namespace. Yep. Yep. Okay. So Michael, before I move on, did you have?
Just
yep.
one other thing that was part of the discussion, which is a little bit interesting,
Mhm.
is there was some, I think I was originally a proponent of, well, hey, we want consistent naming, so why have all the different people invent different names for inverses? So there was a thought on the table, why not put out a suggestion of here's what you should call the inverse property if you're going to have it? And that was eventually rejected for good reasons. We said it's too much like recommending the wrong thing to do, so that's why we left that out.
Yep. Yep.
Well, it was like saying, our best practice is not to have inverses, but in case you do want inverses, here's how we want you to define them.
Right.
Exactly. Yeah.
But I think the most common case where you're gonna want an inverse is where someone's already minted it in the other direction in their namespace. And you just want to declare, you
Yeah,
know, whatever linked open data said is the inverse of what I said.
yeah,
Yeah.
yeah.
And and you don't get to name, there's no point in having a naming convention because somebody named it whatever they wanted to.
Exactly. Yeah.
All right. So the next thing I wanted to cover here was what actually went into the removal of inverses from GIST. And there's more that went into it than you might expect. So the more obvious thing is just removing the definitions of the inverse properties. So GIST effects no longer had that property, so we just removed that from the ontology. But on top of that, you have to be careful to ensure that the formal properties, for example, the domains and ranges, are preserved on the properties you keep. And then you've also got to remove references to the removed properties throughout the ontology. So I wanted to say a little bit about that. So like in one case in particular, we had to ensure that we preserve the formal features of just governs, because we removed just governs and it had pretty substantial domain and range constraints on it, whereas is governed by didn't have any of these formal features on it. Whereas in the past, we could rely on inference for these domains and ranges to be enforced when things were expressed using is governed by. When we got rid of just governs, we couldn't rely on that inference for those constraints. So we had to make sure that when we removed just governs, that we brought over these formal constraints and placed them on just is governed by. So it's just something to look out for if you're removing inverses from an ontology. And then also we removed references to the removed properties. Here's just an example of a class just service specification that had a property restriction in it using is basis for. We removed is basis for, and so we had to use the anonymous property construction instead. We could take the same perspective, but just using that inverse of is based on construction. So we did that in a number of places across the ontology as well. Okay, so I'm gonna wrap up here with some practical benefits, and then we can open things back up for questions or more discussion. But here's some benefits that we've already seen with some of our clients. First is, as you might expect, is related to query performance. With at least one client, we've seen a 10x improvement in query performance with reasoning turned on. So that's a pretty substantial performance when you don't have all those additional sort of inessential inferences being made when you're running a query. You can get much better performance. Another thing is there are some workarounds that we had created, and with at least one client where we had created some custom properties that were not formal inverses of just properties, even though commonsensically they were inverses. So we found it in some cases helpful to take a particular perspective, like if we wanted to take the is part of perspective, but not get all of those additional triples, well, we could mint a property like is part of in a client namespace, but not make it an inverse of just has part, And so we could avoid having those inferences. But it's sort of an awkward thing because you would just expect is part of to be the inverse of has part, just commonsensically. So it kind of puts you in a weird position. You get rid of the inverses in gist, you're no longer going to be relying on this sort of workaround. And then, of course, there are also the benefits we've seen with cognitive load, just not having to worry about, well, which property do we actually choose to map the data in. And that is all I had.
Michael's got his hand up.
Yep.
Can you go back to the previous slide, Dylan?
Yes. Yep.
One thing to be aware of, the middle bullet, using the creating is part of, but not having it be the inverse.
Yeah.
That achieves the intended goal, but there's always, like anything else, there's a trade-off. Anytime you have in gist itself the use of has part and a restriction, or maybe the inverse of has part and restriction, then you're not going to get the benefit of that semantics. Probably won't matter a lot most of the time, but it's just something to be aware of.
Right.
You know, the other one, sorry, I'll let you up in a minute there, but I got the microphone. There's one of our projects, I can't remember which one it was, where people were kind of randomly using one or the other. And so you always had to do a union, if half the people, and we didn't have inference turned on, half the people used has part and the other half used is part of. Every query ended up doing a union because you never knew what anybody was going to do. If you just wipe out one of them, it removes a lot of that temptation.
Right. Yep.
That's a good example.
So in the case of the particular client that Dylan's mentioning in point number 2, the client uses RDFox, which does inference on load. So the problem was there that it was timing out on the inferencing due to, as Dylan mentioned, creating double the number of triples. And this is a pretty large data set.
Yep.
Dylan, there was a question in the chat. Which inverses did you keep and why?
Well, let's see. So I can show you the summary here. So this is the full list right here. In the left-hand column, these are all the properties that we retained in gist, and these are the properties on the right, which are the inverses that we removed from gist, and tried to give you a sense of why we, from a general perspective, why we kept the ones we did. If there are any of these that you're particularly curious about, we could definitely talk about them, and we can try to give you a sense of our rationale for why we kept one over the other. But yeah, if you're looking for the full list, it's right here, and it's also within the release notes of GIST 12.
I have kind of a related and broader question. So is anyone going to miss these inverses? Is anyone going to go to work tomorrow and download GIST and say, oh man, I wish I had those inverses?
Not me. I'm really glad that you did it. I think it's great.
Michael?
Yeah, I was initially very uncomfortable with getting rid of them all because I really kind of like having them, and I kind of was balking a little bit. But eventually, it was the writing was on the wall, and it was going to go that way. And it hasn't been a problem. I realized it is the right thing to do, and it's not that big of a deal, the workarounds. Whereas initially, I was just kind of resistant to the whole idea.
Yep. Okay, now I have another one for you guys. This is a new jump ball question. The same logic, I think, might apply to transitive. Do we need transitive really?
That's interesting.
I mean, you can just put a star in Sparkle and get the same effect. Is there, and I don't know the necessarily answer, I'm just sort of, I think it's a logical conclusion from this to ask yourself, it generates a lot of triples too.
Oh yeah, that was a problem that continues to be a problem with the same client, where we were having the inverse problem. And that's even a worse, I think you just said that, much worse problem.
Can be, yeah.
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 Yeah, or to take a particular example, you know, we have has direct part as a property here. We also have has part. So another way of putting it is, well, why do we need has part? We could keep just has direct part. Is that the idea?
Yeah. Yeah.
Michael, then Philippe.
Yeah, just want to comment. It's a bit, so what we're doing here is very much pragmatically based. We're building implementations for clients, et cetera, et cetera. But what's happening is we've had a similar question about subproperties. Subproperties generate extra inferences. We just had an extensive discussion about inverse properties, which generate extra triples. And Dave is highlighting another example. What's happening here may be the right thing to do, but I just want to highlight it is in a way letting the implementation tail wag the conceptual dog.
Yeah, you know, that's why we, you know, really want to discuss this a lot before we do anything. You do lose a bit, but you gain a bit, and you got to figure out, you know, where's that trade-off.
Well, for those of us who like to advertise semantic technology, and that, you know, you create all this new knowledge that you didn't have before, but now we're taking away all the basis for all, gradually chipping away at the basis for inverses. We're kind of cutting ourselves off the feet. So if you do rely on inferencing, you're gradually, you know, cutting off that benefit.
Yeah.
Michael Sullivan.
Yeah, it definitely gets away from the notion that the graph kind of takes care of itself in terms of all of the semantics and forces the knowledge increasingly on the person writing the queries. You know, in a perfect world, we would want all the inverses, of course, and same thing with transitive too. I mean, but in the real world, transitive is horrible, right? And transverse inverse is even worse because it just exponentiates. But it would be awesome if that was just there and could be done on the fly and was performant. Alas, the answer is no, it isn't. So I get why we're doing it.
I'm just thinking out loud here. What if we had a sub module where you put things like transitive and inverses? So if you didn't want them, you didn't have to take it. If you wanted them, you could take it. Is that too weird?
That could work. Yeah.
It kind of goes in the direction that, I mean, to the question that I had. Oh, sorry. There are multiple hands up.
Go ahead.
Yours was up and then went down.
Finish your thought, Philippe.
Yeah, finish your thought. We were saying finish your thought, Philippe. Sorry, we're
going. Okay, yeah. So he was going to was alluding to previously that if I want to put them in a client namespace, what is a good way to name them? So instead of having multiple names, at least we can recognize them. And if we would have some sub part where those properties are explained, here is how you might use them if you want to go there. But the general idea is that you shouldn't, because then you get better query performance and other benefits. So perhaps there is this idea of having it somewhere as a reference if used, and more as a knowledge source of reference than anything else. That was my idea.
Yeah.
Michael, Schultz.
Yeah, a similar thought, achieving the same goal as Dave suggested a minute ago, maybe have off the transitive properties in a separate place. Another way to do it would be at the triple store level. So in other words, if the triple stores allowed you to say, I want to do transitive inference, but only on these properties. So you could turn things on and off. You could have all the inverses, you could have all the transitive properties, you could have all the subproperties, do whatever you want, if you had the ability to turn them off at the triple store level. I don't, nobody's doing that, but it's just a thought I had.
I don't think there's that much granularity right now. I think you either turn transitivity on or off. I don't think you can do it.
Yeah,
like
I think you're right.
That's what I had asked RDF Box about that, and you can't do it in RDF Box, but it would be a great feature to have.
Yep.
Yep.
Keep through it.
So a few points. I'll chime in. I'll put a few of them into the chat. So firstly, I think there's a substantive difference between transitivity and inverses. Inverses do not add any semantics. They literally just provide another name for referring to things, as mentioned earlier, whereas transitivity actually has a real semantic meaning. So I don't think they can really be directly compared. So that's that point. Another point I wanted to raise was about instantiate or reification, and this is an argument in favor of removing inverses, in that if someone is trying to reify the triples or use a new RDF style, or as it's now being called RDF 1.2, which is going through the standardization process, if you have inverses and inferred inverse triples, becomes very hard to know which one to annotate and to add things like provenance and so on. So that's another argument for removing inverses.
That's a good one.
Really in favour of that. And finally, I just wanted to challenge Rebecca on the statement about linked open data and why that you stated a rule which I wasn't familiar with, which says you can only assert triples which are in your, where the subject is in your own namespace. So I'm not familiar with that rule. I thought the idea of linked open data was anyone could say anything about anything.
No, that's not what I said though. I said you're only able to publish triples where the subject is in your own namespace. It's a matter of practicality. If you're publishing linked open data online, you can't, nobody will be able to find the triple. How can I say it? It's not a question of RDF not letting you. That's not what I meant.
I understood that. I maybe recited your rule wrongly, but I'm not familiar with that rule. Now you've got the question of how do people find your published triples. Now that's a matter of setting the right context or the right set of named graphs in your Sparkle query, but there are techniques for doing that. You can establish a workspace, for example, which is a named thing you can manage, or you can just put from different named graphs in your Sparkle query. But I'm not aware of any rule that stops you publishing anything you like in any namespace.
Okay, Jonathan.
These discussions that we're having now, as we're fine tuning, as you all are fine tuning GIST and its use and implementation, it reminds me of my early days in the relational database world in the after 2000 to like 2005 and 6 and 7. And then once I got into star schema, Kimball, data warehousing after a few years. So I think this is just in semantics, we're just growing past the initial stage and starting to get into a more maturing stage where we have to address these performance issues, what cognitive load and the other things. So it's part of the process, I think, evidence that we are making good maturing progress.
You know, one of the other things you didn't mention, Dylan, and I'm sure you lived through it, was the other part of the change was you had to write a bunch of scripts to change any client data that used the inverse, right?
Right. Yep.
You know, so just that's another thing to keep in mind. If you happen to have used that inverse, we got to do something about it.
Exactly.
Yeah, we offer migration scripts with every major release of GIST. So this was just one instance of that.
Michael Sullivan.
Just a comment. by removing it, we've kind of eliminated any notion of polymorphism out of the box. You have to, if you want that, you have to build it yourself. So just, we're moving away from a smart database to a dumber, more specific one where only experts need apply. And yet I think we're forced into this situation because of the way these things permute and cause slowness in the database queries themselves. So it's a damned if you do, damned if you don't situation, I think.
Yeah. Yeah. And weirdly, I think we ended up here partly at the very beginning of this. I was talking about the schools of ontological design. Is because I think our school is mostly about implementing, and so we're smacking up against these. I think more so than a lot of other folks.
Right.
Inference is a mixed blessing. We all love to have it, but we haven't had it for a long time. And suddenly when we get it, we run into problems.
Yep.
Yeah.
Yep.
Yeah. And the part of maturing is it is a discipline. We're not just selling a technology, but a discipline. And to mature in a discipline, you have to get experience, acquire knowledge, and understand it's complex. Anything in the universe is complex. We're just modeling that complexity, and we're choosing to shape the complexity as best works with, as our need for implementing with customers and our environments and enterprises.
Well, yeah, and our hands are tied because of the technology, but newer graph technology like TypeDB does polymorphism on the fly. So I mean, it's a reality. I mean,
Peter, hand up.
I was just wondering if what we needed in terms of some additional property of a predicate was whether it is to be inferenced on in order to reduce the sort of inference everything if we use it.
Well, everybody hates it when I say this, but my little trick for that one is to make it an annotation property. Then
yeah,
inference goes away. But
yes.
Every time I say that, people go,
yeah, but the thing about it, Dave, is that's a fudge and a workaround. Yeah. Whereas if what we had was something built in, it would be very sweet to be able to be specific about what our intention was.
But we don't have the option to build that in. It's in the standards and it's in the tools and everything.
I know, but those are changeable. They develop. Look at RDF star. It's a case of working out where the standards need to go. Getting involved in that space and steering it rather than being steered by other people that may not necessarily be doing that much implementation.
Isn't that a question of use cases, though? Some people would want to inference on one predicate, others would want another. How do you build that into the ontology?
Well, the thing is, just like you say that a predicate is transitive or symmetrical, you would say that it's inferenceable.
But it is, well, it's a semantic thing. Whether it's transitive or symmetrical is a matter of semantics.
Yes, but whether or not operationally you wanted,
whether you want to inference on it is an implementation question. How do you build that into an upper ontology when you don't know what the implementation use cases are?
And I mean, I understand that you probably wouldn't want to necessarily, well, you'd want it to be optional so that people could turn it off or turn it on in their implementations.
Turn off the don't inference?
Yeah, on a specific set of things. I mean,
I mean, if
When-
you
when
can
you-
turn that on and off in your inferencing engine, then you don't actually need it anyway, right?
Yeah, but when you are fully inferencing things where they end up being subclasses of themselves and various other things like that, you end up with an awful lot of stuff that you really don't need.
I kind of wished I ran into this issue a few weeks ago at one of the customers with Allegrograph, and I turned on the old materializer for the triple store, and it absolutely exploded the size of the database. And I did kind of wish at that time, I kind of wish that there was a way that I could go into the ontology and add a little annotation or an instruction basically to tell like, hey, just don't do this one, okay?
Yes.
I'm interested in this reverse, this inverse, but not this one and this or this one. Yeah.
The point I'm trying to make is that's an issue of configuring the inferencing engine. It's not an issue of the ontology itself.
No, I totally agree. But Peter's point, I think, is that these kinds of instructions they're important to keep in mind when you're building the ontology.
The other thing is, like, if you use, say, something like Hilar, you can work out, you can edit out specific inferences that you may not want to use that often. So, I mean, it's basically bringing that to the fore and making it more readily usable within your RDF, within your graph, rather than having it as something in the back end of your system. Anyhow, just a thought.
Yeah, I mean, I guess I don't understand the point of defining something as an inverse, but then saying don't inference on this. You define it as an inverse so people can inference, and then people tune their inferencing engine as to whether they want to inference on that or not. Just don't see it as a semantic issue.
I think it's particularly helpful in whether or not you want transitives to be inferred and that kind of thing. But
transitives are more, I mean, inference thing doubles the number of triples. Transitive properties potentially explode them.
Michael and Jonathan?
Yeah, the discussion about it's a matter of fine-tuning the inference engine, and inference engines don't provide that. This is where we go back to Dave's suggestion. You could, and kind of what Mike was saying, or Jonathan was saying a minute ago, you could have all the inverses and transitivities and subproperties in a separate file, and then you could fine-tune that. So that way the inference engine would do what it's told to, and it wouldn't have to be fine-tuning the inference engine, but you get the same effect. It's convoluted though, because just turning those things off has other implications, so it may not be so easy to do.
Yeah, maybe you include them at design time, because you want to know that something's transitive, and even in unit test time, if you will, but then get rid of them when you go to production.
Yeah.
Jonathan.
Yeah, that was my point. And I guess the other question I have, and I'm not educated to answer this, is there a need for an additional RDF component or some protocol component that enables fine tuning in implementation that builds on top of it and provides more granular support for this need for customers outside of the core semantic model in the ontology?
Yeah. Rebecca?
Yeah, a couple points about providing these things in a different file or different files. Inverses, you don't really need to do that. People can define their own inverses. Transitivity would have to be defined, by semantic arts. But nevertheless, if you're talking about fine tuning at a really granular level, inference on this inverse and not on that inverse. So we provide a file and you're going to take different pieces of that file. So are we going to provide 20 files, one for each inverse property? It just.
Yeah. Well, I had a fantasy once upon a time, that one file per class and one file per property, so yeah, maybe.
So one file for each, each property, sort of a la FIBO.
Mike Sullivan.
Yeah, we wanted the kind of transitive that kind of skipped several of the nodes. So basically, imagine a tree, taxonomy, and or schema, and you basically wanted everything to be transitive, but you only wanted to know what branch of the tree you were on. You didn't really want to know all the sub branches and all that stuff. So we've had to put that into our pipeline rather than into the ontology. It's a pain, but it works.
That is an interesting one. Yeah, you're right. That's what you almost always want. You want to know what tree you're on.
And sometimes what tree I'm on. Yeah, exactly. Yeah. And you know, it's arbitrary because some people want what tree.
Yeah.
I mean, think of the leaf. What tree do I belong to? You know, so it's it'd be that kind of stuff would be useful.
Yeah, it's a good one. Okay, I think that's a wrap. Dylan, that was excellent. Thank you.
Yeah, thanks, Dylan.
Yeah,
Thank you
thanks
all.
everyone.
Great.
Yep.
Great discussion.
Thank you.
Thank you very much, Dylan.
Brilliant.
Thanks, everyone.
Thanks, Dylan.
Thanks.
Awesome presentation,
Bye.
Dylan. Thank you.